going to solve a simultaneous equation using matrices. All right, so the first thing I'll do is write on the question. So we have the simultaneous equation here, and we are asked to put in form ax equals b, and then solve the simultaneous equation using matrices. Make sure I put using matrices because there are a number of ways to solve a simultaneous equation. So let me write on the question here. All right, so this is a simultaneous equation. We have to put it in this form. So to put it in that form simply means, so the first thing I do is simply write the numbers alone without the letters. So I have 2, 3. I don't put the plus 3 because 3 is understood. So 2, 3. So I have 2, 3, 1, negative 5. So I have 2, 3, 1, negative 5. I have x and y. I'll tell you why it's like this just now. And that is equal to 5, negative 4. All right, 5, negative 4. Now, basically, if I multiply these two matrices here, so if I multiply this by this, I'll get back what's on top here. All right, so just to give a little illustration, watch this. Remember, it's row by column, right? Check out matrix multiplication if you are a little hazy on it. Row by column, so first with first, second with second. 2 times x is 2x, always plus. 3 times y is 3y, right? And that is equal to the first number here, which is 5. Continuing, we have row by column. So 1 times x is 1x, always plus. Negative 5 times y is negative 5y, and that is equal to negative 4. Now note, you can simplify this below here, and we will get 1x minus 5y equals negative 4. So it's the same thing. It's the same thing. All right, it's the same thing. Continuing, we just erase this right here. Remember this said put in form ax equals b. This is the form ax equals b, right? This is a, this is like saying x and equals b, right? Ax equals b. So this is the form right here. So this is part 1. Very simple. Part 2, we go to solve the simultaneous equation. We have to use matrices. So I'm going to continue with part 1. Sometimes the question tells you hence, and hence means you have to use part 1 to solve part 2. All right, so I'm going to use part 1 to continue. So if I have, let me just show you something. If I have ax equals b, and I need simultaneous equation, we have to find out for what is x and what is y. We will say x is equal to a inverse b, all right? X, which would be x and y, we need to find out what are those numbers. X is equal to a inverse b. You have to write a inverse in front, right? If you don't write it in front, the matrix will not be able to multiply. So x is equal to a inverse b. So it simply means I write in xy. That would be equal to a inverse. So if this is a, I can say, right, this here represents a inverse b. What is b? B is 5, negative 4. Right, so I'm on track right here. Continuing, I'm going to take this and work it out down here. So we have 2, 3, 1, negative 5. We need to find out a inverse. So what is the inverse? Now, remember, a inverse is equal to 1 over the determinant of a multiplied by the adjoint of a. All right, so if I need to find out the inverse for this, 1 over 2 times -5 minus, so 1 over 2 times -5, always minus 3 times 1. Let me just make it a little more uniform. Multiply by the adjoint. The adjoint, we simply switch in the positions here. So -5, 2. And we are switching the signs. We are changing the signs here. So I have -3, -1. This is the adjoint, right? This is the adjoint. Continuing. Right, when you're multiplying two different signs is a minus, always minus. 2 times 5 is 10. All right, 3 times 1 is 3. Multiplying two different signs is minus. Put back the 3. All right, multiply by. Now there are some computation steps you can skip. I'm just being a little detailed. 1 over -13 by -5. Right, now this here represents E inverse, which is this here. So let me just put back what I have on top here. 2, 3, 1, -5 inverse. Right. So it simply means instead of writing this here, I am going to write this here. And a next thing to note, when you're finding the inverse, what I usually tell students, don't multiply this here. Don't multiply the fraction by the numbers inside just yet. Hold it, right? Do the substitution here and multiply these two matrices like this here by this matrix here, and then multiply the fraction outside, right? Now that if you multiply the fraction by whatever is inside of here, and then you multiply by this matrix, it will work out. It will work out, but it will be a little more tedious. It may be a little more tedious, but it will work out if you go down that route, all right? So instead of writing this here, I'm going to write my answer below here. So I'm going to say xy is equal to right, this negative sign a little. So you don't have negative sign all here to make your question look like -5 minus 3. All right, so have it a little spaced. Right? Use your room, and I'm putting mark this here as well. 5, -4. Right, so I replaced this with the answer that I got. That's what I did here. Now, realize I ran out of room. I'm going to multiply these two here. So row by column. This here is a 2 by 2 matrix. And this here is 1, 2 by 1. So this here is a 2 by 1 matrix. So we see these two numbers here are the same. The result will be a 2 by 1. So the result, when you multiply these two matrices, you will get 2 by 1. All right. So let's go. First with first, second with second. Change it to purple here. So I have, let me write down open brackets. Zoom it in a little bit. So -5 times 5, right? -5 times 5. -5 by 5 plus, so first with first, second with second, -3 by -4. Right? Nice. You don't have any numbers here to multiply, so we cannot go across. Right? So we finish with the top. Right? If we had another set of numbers here, that will give you this number here and this number below here. But that is not the case here, so we move in below now. So row by column. So I can close my bracket here. -1 by 5. So I have -1 by 5 always plus 2 by -4. Right, so row by column, -1 by 5 plus 2 by -4. Continuing, compute, just simple computation now. So we have -5 by 5. This here is -25. And we have -3 by -4. When you're multiplying same signs, it's positive. 3 4s are 12. So we have 12 here. Multiply different signs, you get minus. That's why you have a negative sign here. 5 5s are 25. Here, multiplying different signs, minus. 1 5 is 5. And multiplying different signs is a minus. 2 4s are 8. So on top here, we have -25 plus 12. And below here, we have -5 minus 8. So continuing. So we have -1 over 13 by, this is -13, and below here is -13 as well. All right. And if we continue, we will get -13 by -113 by -13. If I skip that step, you'll get 1, right? So if I have -113 by -13, this will cancel out. Multiplying same signs is positive. And 1 times 1 is 1. So we have +1 here. It's understood. And I write to the plus. All right. So we have 1 here. And same thing, -113 times -13, you get 1 below here. So clearly, we see in, remember, this is X and Y. So we can see, therefore, X is equal to 1, and Y is also equal to 1. All right, kind of ran out of room right there. All right, so the question is just a little lengthy. Your question doesn't have to be so lengthy. The reason why this question has a lot of work in is I showed all the steps, but you could have, now that you're skipping steps, there are some steps that may not be necessary, all right? But I showed it just to show you where I got my information from, all right? So that's it for solving simultaneous equation using matrices.